Hey y'all, in this lesson we are taking a look at multiplying and dividing expressions that have integer exponents, which means whole number exponents. This lesson's goal is to be able to multiply and divide expressions with integer exponents. A reminder that we will use the word product, which means an answer to a multiplication problem, and quotient, which means an answer to a division problem. So product will tell us multiplication, quotient will tell us division. Our essential question: how do properties of integer exponents help you write equivalent expressions? Our first example is going to take a look at the product of powers. So when we multiply two powers together. The weight of a juvenile alligator, or young teenage alligator, is shown on the right, 2 to the 3rd pounds. The adult alligator weighs 2 to the 6th times more than the juvenile. How can you determine the weight of the adult alligator? Well, because it's 2 to the 6th times to determine the weight, we need to find 2 to the 6th times 2 to the 3rd, which will look like this. Remember from our getting ready that the power, the exponent, tells you how many times you would multiply that base. So 2 to the 3rd is 2 times 2 times 2. 2 to the 6th is 2 times 2 times 2 times 2 times 2 times 2. So 6 times. So we can write those out. 2 to the 3rd is 3 2's multiplied. 2 to the 6th is 6 2's multiplied, and multiply them together. So this is the multiplication sign that was right here. And then this is what 2 to the 3rd is, and 2 to the 6th. And then we can rewrite this because it's all the same. We end up having 9 2's being multiplied. So we say that it is 2 to the 9th. So here's that final answer. But that's a lot of work. We can do this a lot simpler. Our other way is called the product of powers property. And this states that when I'm multiplying two powers that have the same base, like 2, I can simply add their exponents, 3 and 6. 3 plus 6 is 9. A lot less work than writing everything out. You try a similar problem. The local zoo welcomed a newborn African elephant that weighed 3 to the 4th kilograms. It is expected that at adulthood, the newborn elephant will weigh approximately 3 to the 4th times as much as it is at birth. What expression represents the adult weight of the newborn elephant? You should get an answer of 3 to the 8th power. Now we're going to take a look at the power of products property. So we might be asked to find the volume of a cube in cubic inches if that cube is 2 feet long. So the volume of a cube that's 2 feet long is going to be 2 times 2 times 2, which we can see here, volume equals 2 to the 3rd cubic feet. But they want it in cubic inches, so we have to convert. Our picture here is showing that 1 cubic foot, because 1 foot is 12 inches, 1 cubic foot is 12 to the 3rd cubic inches, is what it ends up being. So when we are figuring this out to convert 2 to the 3rd cubic feet, we need to multiply by 12 to the 3rd to figure out how many cubic inches it is. So we've set that problem up right here. And we can expand that out like we did with the first problem. We see it's 2 times 2 times 2 times 12 times 12 times 12. Now we can use the associative and commutative properties. The commutative property lets us move things around. So we'll do 2 times 12 times 2 times 12 times 2 times 12. And then the associative property allows us to put parentheses around those groups. So we can actually create these groups of 2 times 12. We can then, because they are 3 groups of the same thing being multiplied, we can write that as a power. 2 to the 12, and we're going to multiply that to itself 3 times. So this is called the power of products property. When you have two powers that have different bases, but they have the same exponent, You can multiply the bases and then keep the exponent. 2 times 12 and keep the 3. 2 times 12 is 24, so that ends up giving us 24 to the third power of cubic inches. Our final example is going to show the quotient of powers property. So remember, quotient is indicating division. So write an equivalent expression for 6 to the 5th divided by 6 to the 3rd. So to do this, we want to first write it as a fraction. 6 to the 5th over 6 to the 3rd. Remember, fractions and division represent the same thing. And then we'll write it out like we did with the first one. Expand it so we can see what exactly we have. So we have 6 times 6 times 6 times 6 times 6 on top, and on the bottom we have 6 times 6 times 6. We then can see that we have this grouping of 6 divided by 6 times 6 divided by 6 times 6 divided by 6. So because 6 over 6 is 1, we can actually rewrite this as 1, 1, and 1. Which means that we have 6 times 1 times 1 times 1 times 6. Because multiplying by 1 doesn't change the answer, we can remove those and just write 6 times 6, or 6 squared. From here, we can see the quotient of powers property, which states that when you're dividing two things with the same base, you can subtract the exponents. So we had 6 to the 5th divided by 6 to the 3rd. So we can simply take 5 minus 3, which is 2, and write 6 to the power of 2, or 6 squared. So when you are dividing, you will be subtracting. Here are 3 problems for you to try. The answers you should get here are 72 to the 4th power, 8 to the 6th power, and 3 to the 12th power. Here we'll take a look at the summary. So we had 3 properties that we went over, and notice with these general rules, all of the letters would represent numbers where none of those numbers are 0. That's what this means here. None of the numbers are 0. So our product of powers basically says when the bases are the same, add the exponents. Our power of products property says when the bases are different, multiply the bases and keep the exponent. And our quotient of powers property says when the bases are the same, subtract the exponents. Your next steps are to turn in your 9.1a notes, complete your build 9.1a, and take the mastery check for 9.1a. Good luck.